We discussed calculus, differentiation, how to differentiate, differentiation, which is the gradient function, and then the gradient when x is given. For that, we practice all of the exercise. Now we have the chain rule.
Sorry, your voice is a little glitchy. I heard what you said, but it's just like a little bit glitchy.
Okay. So now we are doing chain rule. So basically, chain rule is when we have another variable connected other than x and y. So whatever the quantity will be, we just have to take care if left hand side balances with the right hand side. For example, if we are differentiating this time, this was with respect to u or any other function, if that would be time dy by dx would be equal to if we are differentiating y with respect to time and x with respect to time. Basically, when you differentiate y with respect to time and differentiate x with respect to time, this is how it should be written. X and y in the denominator.
X with respect to time and y with respect to time? Okay.
So both in denominator, but when we write them as chain rule connecting with each other, you see this should cancel out with each other and left hand side is now equal to right hand side, whatever the value will be. For example, we have this value as 7 and let's say we have this value as 4. So definitely we can substitute it like this, reciprocal, and dy by dx will be 7 by 4.
Wait, I don't understand. So dy by dx itself is just canceling out the time?
We won't be cancelling out. I'm just showing that left hand side is equal to right hand side if we write it in this way.
Okay.
So let's do one question. Similarly, as we are doing with the u, dy by dx is equals to dy by du into du over dx. So we have a derivative function, which is y is equals to, we have a function y is equals to 2x plus 3 raised to the power 8. Now we are taking this whole as u. Now how do we differentiate it? U is equals to 2x plus 3. So one thing, we differentiate it with respect to u. That means if we take it as u, y is equals to u raised to power 8. So would you agree? Now we'll do dy over du. First we used to do dy by dx. So this should be 8u7.
Okay.
And on the other side, du over dx should be 2.
But why do we have these like other forms when we already have the formula dy over dx?
We'll connect them and get rid of u.
But
We're
why
trying,
do we have the
yeah, this is a different type because it has a power. We were differentiating these, they didn't have any power, like whole power. This is power comes down, gets multiplied, and one less in power. Then again 3 comes down, 3 5 times 15, 1 less than power. This is one way. I'll tell you the generic way as well. Both are acceptable. So if it comes down, now I can say that with respect to u and with respect to x, you've differentiated. And I can write dy by dx is dy by du into du over dx. Now I'm just copying those values.
Oh, so we just substituted 2x plus 3 to become the u, and then we substituted it that way, and then we expand it?
Yes.
Okay.
And it's the reciprocal. So I'll write as 1 over 2. And we already know what u was. U was 2x plus 3. Now we can replace it. 1 times 2, 4 times. So simply 2x
Why
plus
is
3
du over dx 1/2?
because that's a reciprocal.
We have to take the reciprocal of the
Yes,
dy
see
over dx.
du over dx. But when we write it here, uh, sorry, my bad. I just had that in mind that it's reciprocating. This is 2 and 16.
But how did we know the dy over dx of it though? We just did whatever was inside. We were differentiate whatever was inside. Okay.
Yes. Now we can avoid this and follow the generic rule that y is equals to 2x plus 3 raised to power 8. So when we will differentiate it, dy by dx, we will first deal with the power only. This is 8, 2x plus 3 raised to power 7. Now we will deal whatever is inside the bracket and multiply with its differentiation. That is 2 in this case. So 16, 2x plus 3 power 7. First we deal with power, then whatever is inside the bracket. Another example, y is equals to 3x square minus 4x power 15. That's too large. I want not willing to use calculator. This is, let's say, 5. Now dy by dx. We first deal with the power. 5 comes down. 3x square minus 4x power 4. Now what do? We multiply with whatever is inside, differentiation of whatever is inside. And that was 6x minus 4. And we can definitely simplify it. Multiply 5 inside. 30x minus 20 times 3x square minus 4x power 4. Try this with me. This is, let's say, 2 into x square plus 3 power 6.
So we can substitute u into it.
We are doing it without u. We
Oh,
bring
okay.
power down first. 12 x square plus 3, 1 less than power. This was how we were dealing with power always. Now we multiply with the differentiation of what is inside, and that's 2x. So 24x into x square plus 3 power 5. Let's just get to the practice exercise. Exercise 12.2, question 1, part A. Y is equals to x plus 2 raised to power 9. So dy by dx, first we bring the power down, then we multiply with the differentiation whatever is inside. And 9x plus 2 power 8. See B part. 3x minus 1 raised to power 7 dy by dx is equals to power comes down, and with the differentiation of whatever is inside we multiply, and simplification 21 into 3x minus 1 raised to power 6. You getting it?
We just expand it from the power.
We just what?
We would just be expanding it from the power.
No, we're not expanding it. We're just differentiating. See, differentiation was all the time x raised to power 7 dy by dx. Power comes down and 1 less than power. But this time it is not only x, it is a complete function under the power. So what do we do? Y is equals to, I'm comparing it with this very question. This time it is not only x, this time it is y is equals to a complete function raised to power something. So what we used to do was dy by dx, we used to deal with the power only. Keep looking at left hand side as well. When we do this, 8 comes down and 1 less than the power. We used to do this. But what about this thing? That was x. Now this is something else. Differentiation of x was 1. So we didn't had to go through that. Now differentiation of whatever is inside in this case is 6x. So you multiply with 6x. So 48x into 3x square minus 4 raised to power 7. We are not going in any sort of expansions.
Okay.
These two
But
were without power, they could be multiplied.
okay, and then we multiply that, and we still have the 3x squared minus 4 and the to the power of 7.
Yes.
Okay.
Try question 1 C part. What will be dy by dx?
Negative 31 minus 5x to the power of 5.
Yes, I suppose. This is power comes down, 1 less than power, and differentiation of inside is minus 5. Yes. Negative 30, 1 minus 5x raised to power 5. Very good. Let's increase this a bit. I'm doing K part. Today we have to do more than like 2 exercises. This is 12.2. So we'll
So,
just
okay.
go through the types and take the leaps in order to
Okay.
achieve the target. Let's say y is equals to x square minus 3x raised to power 5. So dy by dx is power comes down, x square minus 3x, 1 less than the power, and inside the differentiation is 2x minus 3. If they would have said that find the gradient when x is 1 or 2, I wouldn't go for simplification. I would just replace x with that number. But for now, we can multiply this 5 with this bracket and 10x minus 15 times x square minus 3x raised to power 4. Try L part and careful with the fraction. X square plus 2 by x raised to power 4. And when we don't need to write equal to y, we can always write that we are applying the function d over dx and differentiate. 12.2 jk.
So first the 4 would come down, so that would be 3x squared plus 2 over x. And then afterwards, we would, oh yeah, 4x squared plus 2 over x to the power of 3. Then we would differentiate the inside, so then it would be 2x plus, so that would be 2x to the power of negative 1, so that would be just minus 1 to the power of, minus 2x to the power of minus 2.
Yes, yes.
And minus 2 over x 2 squared. And afterwards we multiply that with the 4. So that would be 4x minus 8 over x squared. And then multiply that with x squared plus 2
That's
over
not,
x to the power of
it's
3.
8x.
Sorry?
I thought you said 4x.
No, x squared plus 2 to the power 2 over x.
Yeah. So, okay, it's
Oh,
not
and then we would take out x8
simplifying it.
from that one to simplify it further, right? That's what it answers.
Yeah.
Is that
Difference.
necessary, or can we leave it like this?
He missed the 2. The differentiation was 2x. He missed it. No, we can leave like that.
Okay.
Okay. Now these are all of what we are doing, all the types. So how to deal with the fraction? Let's question to F part. It is 1 over x minus 1 raised to power 5. And I have to apply d over dx. So before I apply that, I'm making some rearrangements. This would be written as minus 5. And now I'm differentiating. Minus 5 comes out, x minus 1 less than power, and what's inside differentiation of that. So I'm left with minus 5 over x minus 5 power 6. Main theme stays same. We just rearrange it according to our need and then differentiate. Suppose E part 4 over x square minus 2x. I'm rearranging it x square minus 2x raised to power minus 1. So now I'm going to differentiate it. I'm getting 4 into minus 1 x square minus 2x raised to power minus 2, and into the differentiation, that's 2x minus 2. And I'm left with minus 4 into 2x minus 2 over x square minus 2x whole square. Is that okay?
Yep.
Okay. Try G part. 2 over 5x minus 1 whole cube.
Negative 25 over 5x minus 1 to the power of 6.
Question 2G. Is this the answer?
It's negative 30.
Yeah, are you getting this? Negative 30 over 5x minus 1 whole raised to power 4.
No, I'm not.
Okay, let's try. So I'm writing it like this first. 5x minus 1 power minus 3. And now I'm applying derivative and getting, now first the power comes down. This becomes minus 6 into 5x minus 1 raised to the power 1 less than power. Then I'm multiplying with the derivative. What is inside is 5. So 6, 5 times is minus 30, and that negative power goes down. 5x minus 1 raised to power 4. We're getting that. Can you figure out where you missed something?
I think I messed up probably in the power section with decreasing it, and then I should have
No.
got a negative 30.
Yeah.
Okay. And then again, we put underneath, so it would be negative 30 over 5x minus 1 to the power of 4. Okay.
Yeah. Similarly, in question 3, the powers are now just the fractions, and no rule changes, nothing else. X plus 2 root. Now, this is x plus 2 raised to the power 1 by 2. Before we derivate, the power comes down 1 over 2, and x plus 2 raised to power minus 1 over 2 into 1. If you could notice, let me try all different colors. If you would notice, these type of questions will have 1 over 2 always, and whatever is here comes down x plus 2, and whatever was inside, the differentiation gets multiplied.
But why did we just get 1 by 2? Isn't it negative 1 by 2?
No, it was positive. That
Oh, and
became
then it
negative.
became negative. Okay. But
So
then
basically,
how? So it's always 1 by 2, and then the
yeah, I'll show
bottom
you.
part. Yeah. Okay.
Look at C part. This is root 2x square minus 3. So what are we going to do? This is only in case when we have square roots. I'll write 1 by 2 directly and copy this. 2x square minus 3. 1 by 2 and then copy this. And then multiply with whatever is inside the differentiation of this. And that's in this case 4x. So this should be 4x over 2 square root 2x square minus 3, which definitely simplifies to, this 2 could be cancelled out with this 4, which simplifies to 2x over 2x square minus 3. Let me show you. 2x square minus 3, it was 2x square minus 3 raised to the power 1 by 2. Now we derivate. So what happens? The power comes down 1 by 2. This 1 by 2. Always, because the power is always 1 by 2, that is square root. And then what happens? When we subtract 1, we get negative 1 by 2 always. And in order to make this positive, it goes down. Hence, we get the same shape in the denominator. And then what happens? We multiply with whatever is inside the differentiation of that 4x, this 4x. So if we have like 6x cube plus 5, what will happen? We'll write 1 by 2 square root 6x cube plus 5 as it is. And then the differentiation of this part is 18 x square. So 18 x square over 2 square root 6x cube plus 5. Differentiation is done. Only simplification is left. This. Look at C part. Um, C is done. D part. Question 3, D part. Square root x cube plus 2x. And I'm differentiating it. What do we get? 1 over 2 copy x cube plus 2x into
I'm still
differentiate.
kind of confused about that concept though.
If you're confused, you can go through step by step. Ultimately, you'll get used to it. That yes, it is happening. Again, I'll show you the comparison. So because this was square root, we wrote 1 by 2 first and then copied the same question with 2. And now I'm multiplying with the differentiation what is inside, which is 3x square plus 2 in this case.
Okay.
So this is 3x square plus 2 over 2 square root x cube plus 2x. Now I'm going for this question again step by step. The question was x cube plus 2x power 1 by 2, and now we differentiate it d over dx. So what do we get? We deal with the power first, 1 over 2, and then we subtract 1 from the power, and then we multiply with the differentiation of the base, that is 3x square plus 2. This negative power is coming down. 3x square plus 2 is already there. Because of that negative power, it is coming down. This is 3x cube plus 2x plus 1 by 2. Now 1 by 2 could be written as square root. So that's 3x square plus 2 over 2 square root x cube plus 2x. See?
Identical. Okay.
Okay. So if I write it like this, y is equals to this. So dy by dx would be 1 over 2 square root u into differentiation of u. General form.
Okay.
Let's try one question, keeping this in front of us. Let's say E part. I don't know if I did that earlier. So
4 into x squared minus
the
2x.
a third, the square root. Question 3.
E
3
part. Oh, okay, okay. So it'll be 3 over 2. So 3 minus 2x to the power of 3 over 2.
So derivative is 1 over 2 already there. Square root 3 minus 2x. And then multiply with minus 2.
But then what about the cube roots?
My bad. We were practicing square root. I didn't notice.
But for cube root, it would be different, right? It would be 3
That
over
will
2.
because that's 1 by 3, and when we subtract that becomes minus 2 by 3.
Okay, but it would still be 1 over 3. And then would multiply it with the actual and then multiply it with the differentiation of u,
But
right?
that won't be copy paste now. So square root, let me try with square root. And let's say I'll write it. The questions are done. Let's try the seventh part. We'll come back. Question 7 says find the coordinates of the point on the curve where the gradient is 0. So y is equals to square root x square minus xx plus 13. So dy by dx is 1 over 2 square root x square minus xx plus 13 multiplied with differentiation of what is inside is 2x minus 6. And then it says where gradient is 0. So we substitute 0 is equal to 2x minus 6 over 2 square root x square minus xx plus 13. And we're left with 2x minus 6 equals to 0, 2x equals 6, x equals 3. When x is 3, we can get y. So y is equals to 3 square is 9, 6 3 times is 18, plus 13 square root minus 13 minus 9 plus 13, that's square root 4, and we get 2. So the coordinates are p comma 2 on the curve, and at that time the gradient is 0. For the
Where we plug
case,
it back into the y part is just so I understand how we got the gradient and 0, and then we found out x equals to 3. But then afterwards, we plugged it back into the original, right? So
is to get y.
9. Okay, okay. But then,
Mm, yeah,
so
yeah.
the coordinates were 3, 2,
Yes,
because x was 3 and y we got 2.
yes.
Okay.
Okay, 3 minus 2x raised to the power 1 by 3. Now we differentiate it. Power comes down. 3 minus 2x raised to power minus 2 by 3 into the differentiation is minus 2. Because of the negative power, it comes down minus 2 over 3. 3 minus 2x raised to power minus 2 by 3. The concept of copy pasting was only in square root, not in cube root or any power else. Okay. Try question number 4. 12.2. Question number 4.
Can I just quickly get my charger?
Yeah, sure.
Okay, I'm back. Question number 4, right?
Yes.
Eight.
Question number 4 is it? Yes. So that's how we deal with the power rule. And I'm going for question 5. Find the gradient of the curve at the point where the curve crosses the y-axis. So we know at the y-axis, x is 0 and y is unknown. First, let's find, though x is already known. So at the y-axis, x is 0. Y is equals to 8 over x minus 2 squared. Y is equals to 8 into x minus 2 minus 2. So dy by dx is minus 16 x minus 2 whole minus 3 into 1 minus 16 over x minus 2 whole cube. And we were looking for gradient where it crosses the y-axis, and at that point x is 1. Minus 16 over, sorry, x is 0. Minus 2 cube, that's minus 16 over minus 8 and equals to 2. Question number 5, 2. I'm going for the product rule. Now we'll be having two functions which will be multiplying with each other. For example, y is equals to x plus 1 into x plus 2. These are two functions being multiplied with each other. The general form is u dot v being multiplied. So dy by dx is first function into differentiation of second plus second function into differentiation of first. Now, if we follow that rule, dy by dx is first function into differentiation of second plus second function into differentiation of first, which simplifies to x plus 1 plus x plus 2 ends at 2x plus 3. Now, some students argue that they can always simplify it by multiplying these two and then differentiate. Definitely, in this case, there's no restriction. This is x square plus 2x plus x plus 2. Y is equals to x square plus 3x plus 2. Now we go
So the
for
two methods are basically either we can multiply each one with its differentiated value and then add them together, or we can multiply them together, so expand the brackets and then differentiate it.
in this case, yes. But you'll have different values where you won't be able to multiply them. I'll show
Okay.
you. So now you differentiate, you get 2x plus 3, and the answer is same. So basically, multiplying and simplifying like this or using the formula is proof that we get the same answer. And what it would be, I'm copying the formula here, y equals u dot v, dy by dx will be first function into differentiation of second plus second function into differentiation of first. So it would somehow look like this: x minus 3 into, let's say, x square plus 4 raised to power 6. Now we won't be able to multiply these two. That's power 6. So dy by dx is first function. Now we multiply with the differentiation of second. I'm looking at the second function and differentiating it into 6 into x square plus 4 power 1 less, and whatever is inside is 2x. And then we write second function into differentiation of first. And now we simplify this part. Or we'll have that find the gradient at point x is equals to 1, 2, or 3. We'll just substitute. So trying to simplify this is 6x minus 18. 6x minus 18 still into 2x into x square plus 4 raised to power 5. And on the other side, x square plus 4 raised to power 6. I can take out this is common, which is x square plus 4 raised to power 5, and I'm left with product of these two, 12x square minus 36x, and 1 power is inside still, like this. X square plus 4 raised to power 5, that is x square 13, x square minus 36x plus 4. So their product rule will help us. Okay, exercise 12.3. Let's try E part. Question 1E. This is x into square root x minus 5 d over dx equals first function into differentiation of second function plus second function into differentiation of first. Now we simplify this as x over 2 square root x minus 5 plus square root x minus 5. We can
But
simplify
how is
this.
the differentiate? Oh wait, there's no differentiated form for the x, so we just
Yeah, that's one.
move the 1/2 down.
Yes.
Okay.
I'm taking out square root
Well, why did we put the x minus 5 and the negative 1/2 again?
because that was raised to power 1 by 2. So we subtract 1 and we get 1 negative half.
Yeah, but did we repeat it because it was also on the? Oh no, we did we?
No, no. This is first function into differentiation of second plus second function into differentiation of first.
Okay.
That's how it's coming back again. And if you wish to take that out common, we can still do it. Square root x minus 5 out is common. So x over 2 into x minus 5 raised to power 1 plus 1. would depend on the demand of the question. This was just differentiation. This is done. I'm doing I part. That is 2x plus 1 into x square plus 5. D over dx, I'll do it slowly, is first function as it is into differentiation of second is 2x plus second function as it is into differentiation of first, which is 2. And then we can simplify. 4x squared plus 2x plus 2x squared plus 10, and 4 and 2 is 6x squared plus 2x plus 10. Okay, try J part. X plus 4 into x minus 3 cube. Still doing it?
Yep. I'm getting negative 11x squared plus 69x minus 99.
Negative 11. Which question are you doing?
I'm doing J part.
Okay, let's check. This is 12.31J. 1J. These are not that large numbers.
I think it's a simplified version of my answer. Maybe.
Oh, you expanded x minus 3 whole square.
Yeah.
Okay, 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 okay. I'm doing number 3, then we'll touch 12.4.
Okay.
Question 3. Y is equals to x minus 1 whole cube into x plus 3 whole square. And we need to find the gradient at the point when x is 2. So dy by dx is first function into differentiation of second plus the second function into differentiation of the first. Now we need it at x is equals to 2. 2 minus 1 cube, 2 into 2 plus 3, 2 plus 3 square, 3 into 2 minus 1 squared. 2 minus 1 is 1, 1 cube is just 1 into 2 into 5, 2 plus 3 is 5 squared, 3, 2 minus 1 is 1. 10, 25 into 3 is 75, that's 85. Question 3 is 85. Now the nature would stay same, only the type of question and how to differentiate it is going to change. No new concepts, nothing, only the formula. Now this time we'll have quotient rule as this v divided by u and dy by dx. Before I move on, u thought the product was first function into differentiation of second plus second function into differentiation of first. Now this is quotient rule. We do v into differentiation of u minus u into differentiation of v over v square. In this case, it was possible that you can interchange, but now no, because that's a negative sign. That was positive. It stays fixed. For example, y is equals to x plus 2 over x minus 3. So dy by dx will be v into differentiation of u minus u into differentiation of v over v square. So this is x minus 3 minus x minus 2 over x minus 3 square. Simplifying it further, x cancels out, minus 5 over x minus 3 squared. Any confusion?
No, so it's just still with the differentiation, but then on top it would be only one of them squared. The first one squared.
The second one, the denominator.
Oh, so the second one squared for the denominator.
Yeah. May I write it like this?
Yeah.
As we were multiplying the two fractions, but it was not possible all the time. So is the case, it won't be possible, but just to show if we try, we can get same answers. Now this is product rule. First function into differentiation of second is -1 into x minus 3 whole square plus second function x minus 3 raised to power minus 1 into differentiation of first. So trying to simplify this negative sign changes, minus x minus 2 over, that was minus 2, over x minus 3 raised to power 2 plus 1 over x minus 3. We can take the LCM. That's x minus 3 whole square. Numerator is already there. Plus, now that's single 1. This is single 2. It's multiplied and 1 comes there. Now negative x, positive x goes away. Minus 3 minus 2 is minus 5 over x minus 3 whole square. So we get the same answer. So we follow the steps. We do the differentiation and get the answer. Okay. Let's try this worked example. Y is equals to x cube plus 1 over 2x minus 3. I'll write the formula again. I'm not expecting that you memorized it. U divided by V. So dy by dx will be V differentiation of U minus U differentiation of V over V square. If you try to memorize it, V is always outside. So dy by dx is V into differentiation of U, that is 3x square, minus U into differentiation of V, that is 2 over V square. And now we simplify. 3 2 times is 6, x cube minus 9x square minus 2x cube minus 2 over 2x minus 3 squared. 6 minus 2 is 4, x cube minus 9x square minus 2 over 2x minus 3 whole square. 4x cube minus 9x square minus 2 over this, yeah. The theme is same, differentiate, get the gradient at any point. At higher order questions, they might ask you that find the equation of the tangent. So by differentiating, we'll be getting the gradient only. And then in one of the questions, we found the coordinates, 3, 2. So what you'll do is we'll get the gradient by differentiating and we'll find the coordinates and then we can use y equals mx plus c to find the equation of the tangent.
Okay.
Okay, 12.4. Try the first one. You want me to write the formula again?
Yeah. Yes, please.
Y is equals to u divided by v dy by dx. V differentiation of u minus u differentiation of v divided by v squared.
So then it would be 2 into 5 minus x minus 1 plus 2x into negative 1 over 5 minus x squared.
12.4 number one.
Oh, no, that's just like when we apply the quotient rule, not the answer.
Okay. Okay. Mhm. Now the questions are increasing in length and it's like hard to just solve without writing. So dy by dx is v into differentiation of u minus
1
u
plus 2x minus
into
1
differentiation of v
over 5 minus x squared.
5 minus x squared. Yes.
So an expanded form would be 11 over 5 minus x squared.
11 minus
No, 11 over 5 minus x squared.
x squared. Yes. Okay. Now the nature is same. We just need to practice and try question number 2, finding the gradient.
Okay.
It's a similar thing, but now we can substitute it.
Or
Minus 4.
negative 4.
You getting it? Minus 4.
I was getting normal 4.
Okay, let's quickly check it. Question number 2 is y is equals to x plus 3 over x minus 1. So dy by dx v into differentiation of u minus u into differentiation of v over v squared. And we're doing it when x is 2. 2 minus 1, 2 plus 3, 2 minus 1. So see, this is 1 minus 5 over 1 square. Minus 4.
Okay. Okay, then I see I just did it wrong, like the subtraction part.
Maybe.
Okay.
Last question. Let's do 4. Find the gradient of the curve y is equals to this at the point where the curve crosses the y-axis. So when it's crossing the y-axis,
So
that's
x would be a 0.
0.
Okay. Seventeen over 9.
Number 4 is 9.
9?
Okay. Are you playing V and U correctly?
Yeah, I am. In the way the formula is.
Divided by V, dy by dx. V simple differentiation of U minus U simple differentiation of V divided by V square. So dy by dx is equals to, we start off with V into differentiation of U minus U into differentiation of V over V squared, and x was 0. So when we
Oh, they're
substitute,
being subtracted.
yeah,
Okay. So the VU dash minus UV dash. Okay. Then the 14x cancel, then it's just, yeah, then it's just,
this is 0, 7 3 times 21, this is 0, minus 2 into minus 2, minus 2 into minus 4 plus 4, 25 by 9, also getting different answer. V into differentiation of U minus U into differentiation of V. And when x is 0, this is 0, left with 3, 3 sevens are 21. This is 0, minus 2, question 4 is 9. What were you getting?
I was getting 17 over 9.
And now are you getting 25 by 9?
No, I was getting, okay, so I was writing, but I'm expanding it in the form of the bracket. So I'm writing 14x plus 21 minus 14x minus 4. And I try to simplify off that. So then I get 21 minus 4, which is 17 over
Yeah, that was
9.
difference, like plus minus. But the answer at the back is says 9. So rechecking it quickly. This is V into differentiation of U minus U into differentiation of V over V squared. And we knew that we are working at x is equals to 0. Find the gradient of the curve this at the point where the curve crosses the y-axis. So x is 0. So if I just suppose substitute 0, this is 3 only. Minus, we substitute 0, that is minus 2 into 2 over this is 0. 3 squared, 21 minus 4 plus 4 over 9. That's 25 by 9 for sure.